Okay. We learned over the workshop time that an Ask Me Anything session is quite good because this is the room to address all the basic questions. For those who attended many workshops, feel free to chime in and answer the question. Then it's not as boring as just listening to what you have heard all the time. We see there are a lot of repeating questions again in this. Still creating an FAQ is not the same thing as going through this because sometimes things evolve and so on, and you cannot make sure that people read all the FAQ out. So let's go on. I start with Linux ecosystem part, which is basically the topic for the next 2 days. We have a lot of other interaction. I end up with this like with the ecosystem, but still a lot of things still go around the Linux ecosystem. What makes it interesting? We see it's getting picked up by many different companies. If you just make a quick search for safety and Linux on your preferred web search engine, or don't ask AI actually, this could give you results. This is from the last trials which I had. It, for example, recommended that the Wind River VxWorks would be a perfect safe Linux example. It also said that ELISA already has done the job and saved everything. So we made Linux safe already. That's what AI said. So don't trust in there, better look for press releases which have been out. What makes Linux interesting is the huge ecosystem, the made for flexibility. It's spread all over the world and in space. It's in the supercomputers, web, locally in devices. I don't know how long we will need further to say the same thing about Zephyr, because it's also just spreading enormously. Yeah, if you look for collaborations and safety part in Linux, we had the CO2 Linux MP project, which has been executed also in the OSADL environment. If you look into our webpage, you see that OSADL is actually a partner of the activity and supporting it. And this was discontinued in 2019, and that's where we, as ELISA Project, picked up the topic. And what we actually also see now with the spreading of SDV, more complex things, especially in automotive, that Linux is becoming a topic again. However, when you came from your traditional environment, you have a lot of things to look at for Linux because it's, well, we look into complex systems and Linux is not behaving as deterministic as small RTOS. It's not a microkernel. Memory management is different. You may have caches and all these kind of things. So it's far more complex. But if you also look into traditionally safety certified real-time OSs, you also see that scalability, running it on many core systems, bring complex use cases in, getting the flexibility, updating mechanism, the work you all have to do. You also have to solve this challenge, getting how you do the over-the-air updates, feature updates, and so on. So you see a path of challenging. Either you go with a certified OS, which you have existing, you add all the functionalities and features which you would like to see, or you go the other path and say, here's my Linux. I have all the features, but I need to find an argumentation why I can use this in a safety critical system. And because you're interested, you're here. So where you can see some clash of the worlds, I mentioned this, dynamic memory allocation caches, interrupt handling, non-real-time scheduling, memory management, all these. What we see more and more is also the demand for tools, compilers, development environment, and so on, because this ties in everything, gets into CI/CD systems. So that there, and this is a pure Linux side. And one major thing about ELISA. The other major part is also a bit around standards. So we cannot get completely around them. During the first half year of ELISA, we learned that we can discuss a lot what is the best safety standard to use. And in the end, we figure out most of them demand very similar things, right? We have to provide artifacts on the V model side. You go for requirements architecture, you need traceability, you need proper testing on all various kind of levels, you need argumentation, certain quality things, and you see this as a repeating theme. From this part, I just put some samples of safety, basically integrity standards. We're not fully talking about safety standards always. The difference, the easiest way difference between a safety and a safety integrity standard is the safety integrity standards provides you guidance, ideas on how to follow process, what measures you can apply. And the safety standard would give you concrete direct actions and requirements on it. The easiest thing is like, there are safety standards for toys. And with the safety standard for toy, it will tell you it need to be flame resistant for 20 minutes under this heat exposure and so on. And if you look into an IAC 61508, it will say, through testing, achieve sufficient coverage. And it's on you, right? It's you have to decide on a lot of things. How you do it. It tells you best practices, but it doesn't mention you the tool, the exposure rates, and so on. Sometimes they're for tolerant times or so, but still there's a lot of things left to you, and that's why safety integrity rather than safety standards. What we see as some passes, and I missed to update this to my latest version of slide, but anyway, we have the Root 3S in 61508, which is basically also what Sil to Linux MP used. We have the Part 8 Clause 12 within the ISO 26262 for pre-existing software, which is enhanced, improved, changed, whatever. At least the ISO pass 8926 is something which will make its way into the ISO 26262 in the long run. Sorry for not mentioning the aerospace things in here. There are also passes. In medical, you have software of unknown provenance, soup parts, where it's much easier to get in than open source, but still you apply similar ways, like a Root 3S. And of course, the challenges increase with the complexity. And if you look into today's Linux systems, the complexity is high. So introduction motivation, also the safety standards need to evolve. So if you look into like what we see in the ISO 26262, depending on whom you ask, its demands on the quality management. And when you say, well, if you're in automotive, you should have ASPICE applied, or maybe CMMI as the quality management standard. If you fully work in an open source environment where you have code first and so on, this does not reflect it. Or you see like your system grows and maybe your failure rates, which you were calculating, are not a good match anymore because you will never achieve these failure rates in such a complex system. So this is things where the standard has to evolve, where it needs to move on. That's part also where we discuss, where we try to break barriers and get in sorts. That's ELISA directly. So ELISA is not in direct interaction with the ISO committee and the ISO 26262 work or so, you see, but our member companies are involved, and we have community members which are involved in these kind of things. So they take also the work forward and consider what we're doing. And this is important because we have really growing interest in the industry on safety critical things. We'll see it also a bit later. For ELISA, it's enabling safety critical applications with Linux. I put beyond security because there's often a mix up between safety and security. So here it's about functional safety and not cybersecurity. And you cannot see it because there is the virtual can see, but not the others. That's down here. You can see anyway. So here it says like Linux beyond security. I know that I have to make it more often. It's about dependability, reliability, use cases, maintainability. We have industrial grade Linux distributions. We already heard from people who are in the field of providing products, need to maintain them over many years. We need to collaborate, and ELISA has close collaboration with other projects. Try to get reproducible systems that you can pick up on it. And little things are around elements, processes, and tools. The overall mission is to define the set of elements, processes, and tools, which later on become amenable to safety certification. And this means ELISA is not safety certifying. ELISA will not create a out of tree or a safety kernel or whatever, just help others to create products. And in order to do so, and it's actually one of my favorite slides, in order to do so, to create a system and assessing whether a system is safe, it's requiring to understanding the system sufficiently. And this is important from the aspect because there are companies coming up and say, well, I would like to deliver a safe product based on Linux. And when you ask them, have you experience with functional safety? They say, no, we're new in the field, but we see the opportunity. Do you bring any experience in Linux systems? No, but we see it's heavily used. So if you are in this field, you're welcome to come into the community and learn, but it will be very hard for you to understand the system sufficiently. Also, if you build a product and your answer is, I don't understand anything or much about Linux, I will go to Red Hat and they will provide me with a safe Linux. This can be an idea, but I recommend you to understand your system sufficiently because you are the one who provides later on the full system where Linux is part of it. And you need to understand how you use it. And then you need to also figure out like which parts of it you actually use because Linux can be many parts. So get an exchange with your Linux distributor or whatever, and then figure out if you identify any kind of gaps. So in this, you need to evaluate and update. And if there wouldn't be any gaps at all, we wouldn't sit here, right? But also if we don't believe that we can't close the gaps, we would also not be here. This is my legal disclaimer kind of slide. Because what ELISA project cannot do, and this falls into the system pillar, we cannot engineer your system to be safe. That the one who creates the system knows all the parts of it. And also an ELISA project can just help to describe processes, but we cannot make sure that you apply the described processes and that they're used with certain rigor. The out of tree part I mentioned, and you still have legal obligations. You have liability if you bring a product into the market. So you cannot say, well, I just did what ELISA said, and I believe it's all good. And by this, I don't need to care. And if I get sued, I point it to the community because you cannot bring this. Still, with this limitations, we have a bunch of members. And what is actually seen is that we have changing members, some leave, additional come, but we really come to a vivid system. With a stable member base. And also what I really like to say is that even if we change our premium members over time from the founding members, I think we still have founding members involved in ELISA. But for example, the premium members, which really drive this forward, have been changed since the beginning, kind of almost completely. So Red Hat joined shortly after, I guess, ELISA was formed, right? Kind of, yeah. More or less founding part, but
You joined the Red Hat.
Well, you're there for the Intel.
I was with Intel and
Yeah.
Premium. I joined the Red Hat.
Yeah. Exactly. Right. We bring the work with different working groups, safety architecture with Red Hat, the Linux features. So we see the presentation, which Gab brings in, which Alessandro brings in over time. We paused currently the tool investigation. It has been Boeing who has been involved there, but the lead of the work group currently got other activities. So if there's someone who says, oh, I'm very much into tools, I want to drive on requirements, tooling, or kernel analysis, working on tool qualification parts and so on, approach us. So we can discuss if you're interested in leading a work group. This is just currently paused. Open source engineering process done by CodeThink since a long time. Systems work group is under the control of Bosch. I didn't change to ETAS, but it's the work group which I'm leading. And then we have the verticals. The automotive mainly is covered currently with the systems, otherwise still with us. I'm also happy if someone says, I want to jump in and take more responsible on the automotive part explicitly. So I'm happy to also reduce my responsibility from 2 to 1 work group. And help in the onboarding, aerospace with Boeing, obviously. The space grade Linux Penguin, you can see the space grade Linux is part of it. Plus, we see the demands from satellite systems, which are, for example, taken and has a good momentum. Medical is also paused. This is mainly due to that the use case has been completed, analysis has been done, and it's like, what would be the next use case? Who is willing to provide requirements and so on this. With this vertical and horizontals, basically the verticals feed into the system part, and the other work groups interact to come to various ELISA deliverables. With some examples here, we have the meta ELISA, where Philipp will also present a bit on the meta layers and the CI/CD parts on Thursday, which also is like the reproducible system where you can follow instructions. We have information on SDPA analysis, how to handle requirements tooling with Basil. We brought workload tracing upstream into the kernel documentation, KSNAV as another tool, which is in the Linux features activities. Yeah, Basil already mentioned. We put a guide on RT Linux, which is actually not finalized. It's in a 80% draft, I would say, which could just be picked up and all just being published. We also try to bring it into reference system that you see workgroups and interaction. And this involves heavy outreach also to like Zen community, Zephyr. Then from use case side, we're interacting with Eclipse SDV, Sophie, specifically AGL, because there's this SODEF part. There has been instrument cluster before, so it's served as an integration hub. And then the wider outreach with things like LinaRS, PDX, Yocto project, and it's all about sharing the ideas, solving the problems together, and that's it. I brought short part on events because we have the workshop today, but we also have regular seminar series. You find them, they are announced. If you subscribe to the mailing list, you see these. So this can serve as a knowledge base. We have, for example, safety critical software on open source summits. So we take this now in December again. We had one in Korea, in Europe, in US, so where we try to get a wider outreach. This year again, we will also be at the Linux Plumber site, where we have a half day of micro conference, where we'll see some of the people presenting again and take it as input. And yeah, almost to the end. So I said we speak a lot about Linux. I just came up and looked into like a 5 minutes on where do I had touched upon, which are the projects which I've heard of. And this is just a list in my area of outreach where I know safety critical open source is in place. So there's compiler activities on the VM qualification work group. We have L4E as in from Kern Concept as a hypervisor microkernel part next to the Xen project. There is Ferrocene with safety certified Rust compiler, but there's still the safety critical Rust consortium around it. We have certain frameworks, SPDX safety profile, which helps us. Trustable is a framework which deals with it. We have initiatives like Sophie, ELISA, then representatives like CentOS Automotive SIG, which also goes into this. That's an open source project. Then Halo has come in from Li Auto. Middleware stacks with Autoware part, Icerix, Eclipse Safe OpenBeef, because they have really a strong ecosystem, and basically most everything of it to the one or the other extent has a touch point in a Linux system. So you cannot get around. And I look a lot into the structured documentation, tests, requirements, traceability, documentation updates, how to keep it up to date, maintainability over decades. It's all the topic for those projects, so they all share the same parts. Often they are not developed to traditional V models, strictly to ASPICE or whatever CMMI, what you expect. You get a degree of freedom. You cannot reach out to every developer directly. You maybe don't know them because it's like a virtual environment. Just check, like, can you figure out who is every contributor to a project when you look into GitHub project? Liability is something which we touched. And yeah, then the development process is something which is also for all these kind of projects a good room for exchange. Last slide. I just wanted to show like from the agenda in which we are looking into. So we have like use cases. I counted like around 5 of the talks and sessions which we have during the next days. Touch it. We talk about system architectures and system composition. Also around 5 presentations we'll have it. testing is topic, requirement and their tools. We talk about standards and OSS processes, specific tool focus, Linux kernel parts. And what I really like is that we also go really beyond the ELISA plain scope with having stricter swings needs, the other parts. We have Xen element, SPDX, safety profile. So really cross-project engagement here. And this would bring us 25 minutes roughly for questions before we hit into a break. For virtual participants, you can raise your hand and unmute, or you type a question in the chat, however you like. If there are questions from the audience, I'm happy to pick them up. And if we have questions in the back, I may even bring a mic or I repeat the question. We'll see.
I'll repeat the questions. We're not running too much back and forth.
Yeah, maybe we can repeat the question.
So, yes, I will start. If it's on the previously asked questions, maybe then, yeah, sorry. Does ELISA have safety specification towards Linux? A document that governs what exactly is requested of Linux being a safe system?
We don't have a full specification on this. It's as some parts really rely on how you use Linux later on. But what we have is that it has certain features and that we write documentation around it, that we update documentation in the Linux kernel. We have the part from GAP, which we go to formal specifications in the kernel, and we also assess certain parts. If we look like we have the minimal kernel parts and looked into what is really the minimal set which you will need in any system. What are components, what are most critical components? We try to find issues, gaps, and describe what can be expected, but it's not a specification, but it's documentation for kernel parts so far.
Do you
Will add something?
that directly to a specific example that I could?
I'll present a specific example later on during the session. But point is that Linux was born as a general purpose operating system, and can accommodate thousands of context of units. Right. The problem is that when you develop, when you define safety requirements on top of Linux, usually these are associated with a specific context of use. So to this extent, this is something that we could do in the vertical working groups, like in the automotive working group. If if there is like a specific use case that we want to analyze, or we did that in the past with in the medical working group where we analyzed a specific use case, then we derived some, we defined some safety requirements already on top of Linux. But when you look at the Linux internals, right, without a specific context, the best that you can do is to define the expectations from the code. What is the intended behavior of it, right? And to document this and to test according to this intended behavior. Then later, when you integrate Linux into a specific context, you may want to assess, the document, the intended behavior against the safety requirements are already on top, and figure out if it is suitable or not, if there are gaps. And also with respect to your context, what is the amount of evidences that are available with respect to the scope.
So it's done bottom up, that the final user has to then connect to the, let's say, low level requirements that are derived.
It's both top down and bottom up. Top down, you can nail down the safety scope of Linux in your specific context, and bottom up, you can gather the evidences that you have with respect to that scope to see, if they meet, if from a systematic capability point of view, you have enough evidences, or you need to something, or there is nothing and you need to implement safety mechanism, you need to take a different approach.
Has this been done at least once, that the company will do this top down and so they would have something to match with the lower level. In public examples,
I mean, the medical use case is a good analogous example. So, and this is documented. These are medical work group results. What has been done, we use the OpenAPS nodes, which is an artificial system part, which is running on a Raspberry Pi. Monitors the glucose level and then controls your insulin pump. And the medical devices work group was taking this use case because it was product in the field by a community, and there was the SDPA analysis to break down the requirements or the demands, what are potential failures which could cause on the system, and then bring this down at the end in the last level with even tracing system calls. And how this analysis was done, this is documented. Is what I would have said, like the other parts where we look really down on the Linux features part, somehow which the OSS workgroup also did with Igor. It's really down on a certain level. And it doesn't mean that what is done there down at the lowest level will really plug together with what has been analyzed top down, right? Because it's wider and it may not be an issue for the use case. You cannot connect those worlds properly and say just, okay, we take the old parts and then we just map it to the medical one. And we also once started on from a top-down part, but this is 100% complete. We also did some work in the for the Telltale use case instrument cluster in the automotive, where we just put in our requirements and try to derive an architecture and bring things forward. There is some example, and we can just look for later on for some things to share with us there. Yes.
Philipp, maybe you can mention, I mean, ELISA exists, let's say 6 years, right? So, and there were expectations when it was created, right? So it was established. Can you tell maybe, you know, from your perspective, what was achieved? Maybe a few points, you know, from major achievements, let's say, and maybe a couple of things which were not run as expected, you know?
So the question was, I don't know if it was really picked up properly. So the question was basically, ELISA runs for 6 years, more or less, a little more even. And there were original expectations on what of these expectations from the original part have been fulfilled, where have we potentially failed over the time, what couldn't be achieved, what have we expect differently. One thing, what we definitely have achieved and what I judge as an achievement, we made kernel patches. This was expected that we somehow work with the Linux kernel. The requirements work, which we currently have, which we're now discussing with the Linux kernel mailing list and will discuss another time at Plumbers. This is a success because it shows we're in direct exchange with the Linux kernel community. Where we still can improve is on the amount of openness and collaboration from industries. So it's we spend a lot of time in writing down our requirements, assumptions, architectures, and we basically documented also a lot of work which has been existing in all the companies and the products and so on. But as we are talking about safety critical products in regulated industries, there's also a long history which is bound to NDAs, intellectual property rights, those and so on. And this was really hard for us, for example, when we started with reference agreements, we wanted to find the community hardware where we can have virtualized GPU drivers, which are available as sources and run them properly. And this is something where we really had hard time. So we changed the reference hardware multiple times because we couldn't come to the performance, or we need to sign NDAs or so. This is something where we could have done better.
Yeah, I also say that one of the things I think is reasonably successful is when we start looking at medical, start looking at that open use case, we actually had something to study outside of the NDA context, which then gave us the ability to start looking at the system theoretic analysis. And then that was reapplied into some of the other groups for extending as a methodology that seems to be a reasonable way of starting to tackle the analysis of the system. And we took it down to the level of the kernel, and we actually came up with trace methodologies for that. We've upstreamed that into the kernel. So those
Yeah.
pieces I would consider a success
Yeah.
at this point in time.
I think, yeah, what you also about the SDPA part
Right.
is something, what I also would judge as a success is like, yeah, SDPA, of course, was pre-existing. We gave examples how to use it, and we saw that it was applied also by member companies, so the member company using it, and you find it also today that it's of use. So whatever example we brought up and we explained, it's not that they followed us and just did it because we did, but you find something, you have something from your industry domain where you can look into and you get practical example of how things work. This was, for instance, also with Bazel, which is a requirements tool which we have. It's actually in use by Red Hat internally, right? So you brought it in and you use Bazel. So it's nothing which is just made by the community, but it's in use. And also to see that we get these interactions with other communities, and that we hear also now that it's getting picked up, that we get more and more people talking about Linux and safety. That's something we see as a good progress, and that we are on the right path still, also after 6 years. Yeah, I think what is still pending part is that many believe that we deliver a safe Linux, and this is what ELISA is not doing. So this is a repeating pattern since 6 years, which we always have to explain that you cannot wait for it. And my personal feeling was also that people come and say, when will you deliver a safe Linux? And at first I think we don't deliver it, but when will we see the safe Linux products? And at this point in time, I will come back, right? It's like, how long will you need? And I will come back when we're done. And that basically results in, it takes us longer than it should. And this is maybe something to really get the people who are interested to on board, joining, get them into the community, doing ambassador and promotional work for open source and open collaborations, also in regulated industries. That's a big topic still to, since 6 years, improve and get it through, because management change, people change, they need to continuously.
Yeah.
Very big question. Yeah.
Maybe another question.
Yeah.
What confuses me, like if we are talking about Linux and safety applications, is it a Linux kernel appeals? Because you cannot consider only Linux kernel, right? So you need libc, libc++, whatever, all dependencies in your application. So ELISA, is it only Linux kernel stuff?
It's not only Linux kernel stuff, it's a lot about Linux kernel stuff. That's our core part. But and it also, because even there we start struggling in finding a common base, right? So because there's so many configurations, so many options, architectures, and so on. So this is the core of it. And then looking into where you should, if it didn't come up over the virtual audience, was like, where do we end up? Do we just take the kernel, or do we go up in higher levels, libc, C++, and so on? And what we have the systems part, for example, right, where we put it into the context. It says enabling Linux in safety application, and this means you have a system which has a safety responsibility, and Linux is part of it. Of course, the ELISA goal is that as much as useful safety responsibility is brought to Linux, but we also tackling challenges where Linux is part of the system, and maybe an interference part, or just quality manage and so on. So we take this as scope as well, but we always try to focus where possible on the Linux kernel parts. We just say like, that's where we want to look in, where we want to give the most time of.
There are a lot of other projects that are focusing on safety. However, Linux is such a complex beast that we need to have a group that can say, here's the ways to tackle in a structured fashion, and that can be used across multiple industries. And so the focus, the heart of ELISA is Linux. On the other hand, it doesn't make sense to look at Linux as safety without a system context. This is why we have the verticals and horizontals. And so this is, you know, the automotive, the aerospace and so on.
I remember for the C standard library, we made some work in the past, probably as part of the tool investigation working group with someone investigating the application of the code coverage inside the C library. Yeah. So it is our work made as part of the ELISA, one of the labs that's particularly to that working group. Yeah. So that's also something, you know, that is not only kernel or Linux kernel, but also.
We know the Linux kernel is the most difficult.
Yeah.
Yeah.
I guess we had this discussion for quite some time ago, where it was actually about the term of Linux, and the term of Linux is used ambiguously, but if you are precise, actually Linux means the Linux kernel. Otherwise, you would have to say new/Linux if you're talking about what you are referring to a Linux distribution. Everything else around. So we had discussion for quite some time, and most of the focus is on the Linux kernel.
Yeah. The other thing too is the Linux, in some ways, if we can figure out how to solve it for safety, we can also apply it to a lot of other open source projects. Right now, Linux is running at 9 commits per hour, roughly, and 1 bug fix per hour, roughly. So that scale. Now, most of it is not in anything that's critical, to be fair. I mean, most of the things will not be compiled into your system, okay? But we have to be able to handle that type of volume at scale, which is a really interesting problem, quite frankly. So figuring out how we can get to there and what's going to work, it's research. And this group is a study group for figuring out part of that research.
And it's also that the work, as you say, the work results can also get in different applications. So like if we are knowing how we handle this kind of change rate of 9 changes per hour, roughly like this, and if we know how to have proper update mechanisms, this can also help in your product development. So if you develop a product which is even proprietary, you can still benefit from the methodologies and the ideas if you just transfer them. And I mean, that's also the work which we are doing. So it's could be interesting for you as a product developer, even if you're not using Linux directly, but to benefit from work elements which we provide. Let me not ask a question, but related to it, which, I mean, this question came in the past as well. So this is one of the questions which are here and there, and often after also came the question, what about hardware? How much are you taking care about hardware? So we try to avoid to look into specific hardware parts. For use cases, we put maybe certain considerations or assumptions to hardware. For example, we would assume that there is a proper watchdog available if we do a design of a use case or so. But I remember that we tried to came without architecture, right? And then we wanted to go to the minimal final config. So Alessandro.
So yes, in that context, that can provide some points. So in the Linux feature working group, we are trying to look at the kernel feature that helps in some context. And this is made particularly difficult because the kernel is compiled by configuration, and most of the configuration depends on the hardware. So as a final statement, you cannot say anything about Linux without saying before which hardware are you considering. We are talked and debate about this particular problem because it was something that was the interest of the working group just to start working. And our conclusion was that adopting an hardware that is generally available and generally similar to other was the best way to get out of this. And for this reason, the Linux Feature Working Group is currently using the AR64 in virtualized fashion in order to make this consideration. Now, these considerations are mostly general, because for some subsystem, you can say things without referring directly to hardware. But for example, for the topic that I will present, the hardware is important because how a system use the memory depends deeply from the hardware. So in this context, I think that the Linux Feature Working Group will use a particular hardware. Then if there is any particular need by any participant or anyone else, we are open to discuss to introduce some hardware, some other hardware. But consider that once you introduce a new hardware, you need to reconsider some of the statement you already made, which is why we decide to focus on one particular.
Then this specifically can also, if you get a proper understanding what impact hardware has, this can, for example, also help you later on in arguing diversity on things. So say you build up a use case and you say by mixing RISC-V with ARM64, and you run your specific use case on it, you can say like, I get a certain argumentation why potential errors will not show up due to different ways of drivers, or how you can eliminate and say, okay, I go in a 2 out of 2 argumentation, and then I will detect certain errors, or the errors don't care. So it's like the system aspect of it, and it makes sense to understand more about the environment which you're in. And currently we're also concentrating on ARM64 because it's seen as the architecture mainly used on a broad set of chipsets as like the core architecture, right?
Yes, it is mainly driven by the customer, but the participant needs.
Yeah.
So the ARM64 has particularly adapt to some constraint about consumption, the power consumption. So it best fits a lot of use case, seems to be the more used so far. Probably things may change with the time. I envision one time RISC-V to be one other major pretender for this place. I do not think that, for example, S390 will ever be in a car, for example. I do not see a mainframe in a car anytime sooner. In any case, I think that with the time, things may change. And when the times come, we are here to see this change.
Right. So I guess this, I would close the session, and you can continue to ask the question also during the break. As the next session will be virtual, I would like to ask everybody to be here again in time, in 15 minutes, so 2:45, so that we can listen to Matt and Martin.
Martin's on time.
Yeah, Martin's already online.
Thank you.
That big project. You know what the name of it is?